Hello everyone. For this week's tutorial, I'd like to discuss the control/conditional blocks. The blocks are called control because they control the flow of the code. And they can also be called conditional because they wait until the code reaches a certain condition before it continues executing the code. The first and most simplest of these is wait integer number of seconds, which simply makes the line of code stop and wait the specified amount of seconds before continuing. Like this. The next option is called repeat integer amount, which repeats the code inside the block the specified amount of times. Like this. Note that there should be an element of timing in your code, like in this example, so that your code isn't repeated the specified amount of times right away. The next control block is forever, which is like repeat, except it will repeat it an indefinite amount of times. It won't stop after a set number. The next block type is if conditional then, which stops the code from executing until the conditional is met. The option after that is if conditional then else, which works similar to the first one, except this time you have an alternative under the else block so that the code isn't kept waiting. The next option is wait until conditional, which works similar to if conditional then, except it will stop all code after that point executing until the conditional is met, not merely the code inside the block. The next option, repeat until conditional, repeats the script indefinitely until the conditional is met. The next option is stop, which stops a certain amount of scripts. The other options in particular being this script, other scripts in Sprite, which means all scripts except for this one, and finally all scripts period. The last control options are about cloning, which refers to making duplicates of an object. The first of these options is when I start as a clone, which is what the script jumps to as soon as a clone is created for the clone. The next script is create clone of object, the default option being myself, which creates a clone of the object the script is applied to. If there's more than one object in the game, you can let it create clones of other objects as well. The final option is delete this clone, which removes the clone instance and all of its scripts from the game. You may be wondering to yourself how quickly a costume can get switched if it is put in a loop, like repeat 10 times. Because unlike playing a sound, a costume switch does not have an identifiable amount of time. So we will first drag the appropriate blocks in, repeat 10 times, next costume. And we notice how quickly that went. You could barely blink your eyes before it stopped. This is because the speed it executed at is what is called the processor clock speed, which is different for each computer as they all have a different central processing unit. This refers to how many times per second code is executed. So for example, a 2.6 gigahertz processor would be able to run 2.6 billion instructions per second. For this reason, the smallest amount of time possible on a computer is called a tick and refers to one clock cycle of the processor. Going back to what was mentioned earlier about 32 versus 64-bit processors, you would be able to determine the bit rate or the amount of bits per second a processor can handle by multiplying the bit depth of the processor, either 32 or 64, by the clock speed, which by definition is how many times per second it switches the bits on or off. Similar to sample rate for audio. Therefore, at the same clock speed, a 64-bit processor would be faster and better than a 32-bit processor. As even though they have the same rate, the 64-bit can handle more bits per second in total. The other type of processor specifications that come into play are the amount of cores and the number of threads. A one-core processor would only be able to handle one task at a time, according to the bit depth and clock speed. Whereas a two-core processor could split the task evenly between the two cores, so that if you have multiple codes running at the same time, like a broadcast message, you would be able to have all of these codes running in sync, instead of just having the clock run the codes individually and switch very quickly between them. There is also an option on many processors for what is known as multi-threading, which means that each core will actually simulate two cores at once, even though there is no physical increase of cores, so that you get an even faster performance. However, not every processor is built the same, and so not every processor will support it. In fact, very old processors don't even have more than one core, so you cannot actually run it as efficiently as many modern processors can. With all the technical details of the processor out of the way, we can understand how the broadcast would lag if it is used too much, because a single script would go by the clock speed of the processor. And if you were to put a broadcast script and then another script receiving the broadcast, then a single core processor would be half as efficient, as it now has to spend one clock cycle each for the two scripts. However, if you were to have a processor with multiple cores and also multi-threading enabled, then having multiple cores running at the same time wouldn't degrade your computer's performance. However, one caveat to this is that processor speed and processor cores alone is not enough to make your games run fast. As for example, if your computer does not have the necessary amount of RAM required to run the total amount of code running in parallel with each other, then your performance will drop below the specifications given by your processor. And also, if you exceed the total number of threads in your processor, i.e. by having more codes run in parallel than threads you have, then your performance will also start to drop in that way, as you are running the code in a manner that the processor is not designed for. One final technical detail to note is that for 2D games, you have a video card either inside your processor or separate from your processor that has a specific pixel fill rate. And the pixel fill rate is simply the fancy way of saying how many pixels per second the graphics card can display on your screen. You often see the pixel fill rate given in the peak amount, which refers to the maximum amount of pixels per second the video card is designed for. However, most high-end video cards nowadays are in the gigapixel per second range, which is definitely more than enough for most screens, as most modern screens, like the one I am using, are 1920 by 1080, which means that there is 2.1 megapixels per second displayed on the screen. However, if you happen to have a lower pixel fill rate on your graphics card than your screen resolution has, then you would potentially experience lag in your display that way, which is different than, although equally as problematic as, lag in your processor. Now that I've given you the technical information behind the hardware for 2D gaming, I can begin teaching variables starting next week and how to work with them in the Scratch engine. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.